Alright guys, thank you. The microphone is being done. No, it's alive. It just took me 3 minutes to get there. Alright, ready?
What?
You did your head? That didn't work. Alright, number 84, what you guys do?
Yeah,
Product rule sounds great because there's a times. Remember, we're taking the derivative of both sides, right?
Yep.
Derivative of the left and the derivative of the right. Kiddos, you had tons of time to collaborate, so right now you're focused. Thank you for your patience as I try to get my microphone working. Love technology. Second, D first plus first. D second. What's the derivative of L and Y?
1 over y.
Why do we need a dy dx? Because we're taking the derivative of the y, and the u prime is y prime, which is dy dx. If you guys notice on CalcChat, they're using y prime. Why do I say not to do that? It looks confusing with the y's. It looks confusing with the y's. Then we end up with, did you guys subtract the ln y to the other side?
Yeah.
Nice. So you get negative ln of y. You can divide the x. You can multiply the y, right? He multiplies, he divides. And we end up with, does it match anything?
B.
B. Woo! There we go. Number 85. What is the slope of the osc? What are they asking us to do? They say slope of the tangent. Derive it. And am I going to get y by itself? I'm going to do implicit. Derive both sides, right? Derive both sides. So I'm going to take 4x cubed minus, how do I do the derivative of this puppy right here? Radical. I have it times. So I'll do second d first, which will be 2xy, plus first d second, which will be x squared dy dx, plus 4y cubed dy dx equals 0. Why 0, not 1? Derivative of both sides, and the derivative of a constant is 0. Then I have to group my dy dx terms together and move everything else over. That's a minus now. He's going to be a plus on the other side. He's a positive now. He's going to be a minus on the other side. I'm moving them because they don't have dy dx. You guys should have gotten on this side all the dy dx stuff and factored dy dx out. And you would have had 4y cubed minus x squared, if you wrote it nice with the positive part first and the negative part second. Then you would have divided. Wait, did anybody start looking at the multiple choice answers early on this one and say, hold on, why are there only numbers? You have to plug it in. They wanted the slope of the tangent at 1, 1. So at 1, 1, we have to plug in 1, 1. And plugging in over here. Nice thing is it's 1, 1, right? 2 times 1 times 1 is just 2. Minus 4 times 1 is 4. 4 times 1 is 4. Minus 1. And we end up with negative 2 over 3. Answer is B. 4 minus 1 is 3? Wait, hold on, right? Negative 2xy adds to the side positive. That subtracts. This one is a negative. That one is a positive. Divide 2 minus 4. 4 minus 1. Aww. Christian.
When you're doing the product flow in the middle, and you have to take the derivative of just the y, so you just write dy dx?
Think of it as derivative of x is just 1. So derivative of y is 1 dy dx. So I just kind of go quick dy. Good question, no question. Number 86 is our last one, yeah? If x squared plus y squared is 100, they were both B? Uh-oh, on the AP, guess B. Just kidding, don't do that. It's horrible advice. If x squared plus y squared is 100, what is the value of, what do they ask? Second derivative. So you should have found first one. Derivative of both sides When you solve for dy dx, the 2's are going to reduce and we end up with negative x over y. That looks familiar. Is that a homework-ish one? I think so. Then we have to derive again, because it's a second derivative. Derive the left, and we get our snazzy second derivative, d squared y over dx squared equals. How do we derive a top and a bottom? Quotient rule. Just don't forget dy dx when you need them. But you don't need them first of all, because it's bottom, that's just a y. The top, which is negative 1, minus its quotient rule, top. The bottom, so Christian, here's another one. I see just the y, and I'm like, whatever, dy dx. All over bottom squared. Huh? What's something I have to do?
Plug in the negative x over y.
I have 2 plugins. I have one right there, and I have one right there, right? So then, I'm going to plug in, just for sake of simplicity, I'm going to plug in dy dx first. So I have my negative y. A negative negative makes a positive. X times, negative x over y. Technically, is there anyone looking over your shoulder saying you can't plug in the numbers until you simplify the complex fraction? No. So if you want, just go plug in numbers now. Whatever, you're just trying to get the right answer. Maybe it'll save you some time. But if you're like, no, if I plug in numbers and the numbers are going to be ugly, then you can go ahead and you can just simplify it the way you want it first. What should we do? Simplify or plug in? I heard plug in. For those of you guys that wanted to simplify, I probably would do that too, but it's okay. What was our point? It's positive 6, positive 8? Okay. So negative 6 plus, 6, 8. I need to write this. I need to visualize. X is 6, y is 8. So negative 8 plus 6 times negative 6 over 8 all over 64. Yeah? Simplify that puppy. And some of you are like, well, he could be a 3 and he could be a 4. So then I have negative 8 plus minus 18 over 4 all over 64. I still like my multiply top and bottom trick. I don't know. It's easier than getting a common denominator. Blech. So then I get negative 32 minus the 4's cancel on the next distribution, right? 18 all over 64 times 4? 256, right? Is that right? And then we have negative 32 minus 18. Ah, stink-a-dink. That ended up being negative 50, right? And some of you might do some factoring and stuff to not have to do these big math facts, but either way we have to reduce, we have to simplify somehow. 5 won't go in, 10 won't go in, 2 will go in. Anything better than 2? 4? No. 2. Alright, so on top we have a negative 25, and on bottom we have a 1, 2, 8. And the final answer is, okay. Questions? I like these multiple choice because they didn't go into that logarithm differentiation we haven't quite mastered yet. But they did practice or have us practice with implicit. First derivative, second derivative, plugging in the whole shebang. Any questions on these ones? We're good? We're golden? We're ready to go? Go team. Alright, good, get that spiral on here. Wait, homework! You're gonna check homework tomorrow. I'll explain why in just a second, but let's get back up notes. Remember how we didn't finish our logarithmic differentiation stuff yesterday?
Yeah.
You notice the lens don't fit on the yeah, very sad. Non-alcoholic. It's called it was on sale.
Right.
Not even?
No copy.
Maybe somebody actually grabbed them.
What?
Alright guys, here we go. Ryan, struggle, that was totally just recorded. Alright, so we're going here, but not yet. We're going back to here. Go back in your notes where we left off yesterday. There are 2 more logarithmic differentiation examples I want to show you. One of them is crucial and the other one is helpful. One of them is crucial and the other one is helpful. Then we'll be done with section 2.5 officially. Homework should officially be fully attended by tomorrow, but hopefully a lot of you got a lot of work done on it last night, this morning, etc. Why am I not having us go over the homework that you should have attempted right now? Well, I'm splitting section 2.6 into 2 parts. And actually homework doesn't yet display that. I'll work it out during 5th period. I have a little bit of time so I can work on it. So homework 13 is going to be section 2.6a, which is going to be a shorter portion of the homework that's already up there. And depending on what we get done tomorrow, we might want to get that one attempted by tomorrow, but he's not a full homework. He's not a full homework. He's a partial. So hence why I was like, yeah, we can give a little extra time on the other. Yesterday, we ended with, just because there's not a logarithm doesn't mean we can't put in a logarithm. And why on earth would we put in a logarithm? Okay, let's focus on calculus. Just because there isn't a logarithm, that doesn't mean that we can't introduce a logarithm. How, though, did this 1/3 come about? Why did it come about? Because it's a cubed root. And why is it so helpful if I have a logarithm? Or why is a logarithm so helpful if I have something raised to a nasty yucky power? Because you can bring it down. So how would we derive at this point? How would we keep going? ln of y. Who's his derivative? 1 over y times y prime, or 1 over y times dy dx. You know that from implicit, right? We do the ln, then since there's a y, we have a dy dx. Equals 1/3, not product rule, because 1/3 is just a constant. Don't try it. It's just a constant. And every coefficient can just stay, right? But how do I derive the next piece? Because it's not 1/3 plus, so I need to take the derivative of 1/3 separate, it's just 1/3 times. The same reason I don't take the derivative, the same reason I don't take the derivative when I have 5x squared. I don't take the derivative of the 5. What do? Make it 10 because I keep the 5 and I derive the next piece. That's the constant multiple rule. It says, hey, he can stay. Same thing here. 1/3, hey, he can stay. If we did product rule, it would be second d first. Well, that's 0. Forget that. First d second is all we need. Ella.
Wait, why does it say 1/3 instead of 0?
That's what I just answered. So over here, real quick, when we take the derivative of 5x squared, do we take the derivative of the 5 or just leave the 5? Leave the 5. Okay. Same reason, it just looks more complicated. Same reason, it just looks more complicated. Keep the 1/3, he's just a coefficient in front, there's no plus. So he gets to stay. I'm taking the derivative of the function next to him. What's the derivative of ln of 2? Well, what's the derivative of ln of anything? 1 over whoever is there, which is all of this stuff, right? Times u prime. Which, looking at this inside, now, might people asking about the constant. Do I take the derivative of 2? Yeah, it's a plus. So 0 plus, what's the derivative of tangent? Secant squared of x squared. Why am I putting another one? Took the derivative of ln, 1 over. Took the derivative of tangent, secant squared. Now you take the derivative of x squared, which is? 5. Right? Now I just need to make it pretty. Than it is right now. So, over here on the right-hand side, let's see, what's on top? The 2x and the secant squared of x squared. Who's on bottom? The 3 times the 2 plus tangent of x squared. Okay, it's a little bit better, but who's on the left? 1 over y dy dx. The question, who do I want alone? dy dx, but that's not true unless I do what with the y? Multiply it. Get rid of them from one side. Ugh. Put them on the other side. Here's the problem. Isn't this all in terms of x? So then you put a y in there? Like, you were so close. Like, you almost had it totally in terms of x. Here's the dealio. They're like, yeah, you better not leave it y. What? You better not leave it y. Because you know who y is. Why didn't I circle the ln if I'm looking only at y? Because I added the ln. The y was just, look at the colors, was just the square root. Now, I'm actually going to write this, even though, sorry, cubed root. Even though it does have a cubed root, I'm going to actually write it to the 1/3 power. Can anybody figure out why? Because we have something on the bottom. What do we do when they're like bases with the powers if that's a 1/3 and that's a 1? Subtract. When you're dividing like bases, you subtract the powers. Like if I was to give you an algebra 1 thing, like x squared over x to the 5th. Subtracting gets us x to the -3. Does that make sense from what you know? 2 minus 5 is -3. That's 1 over x cubed. If I wrote 2 x's multiplied and 5 x's multiplied, wouldn't you cancel out and only have 3 left? So how do I subtract over here with something a whole lot worse? Whatever, they're the same. What's 1/3 minus 1? -2/3. Which means I'm going to have that whole mess raised to the 2/3 and in the denominator because it's a negative power. So 2 plus tangent of x squared to the 2/3 is my dy dx. And some of you guys are like, shh, you told us we could stick it to the man, so I'm going to leave it here. No, you're not. Plug in the y. They're never going to leave that y still there. If all the rest is in terms of x, never leave that y alone. They'll say something like it's a derivative in terms of x, and you would be wrong because you didn't get it totally in terms of x. Totally fine to stick it to the man right here, or you have everything in terms of x over here. But if it was a multiple choice, I promise you to make it match, they would have gone that last step. Okay? Logarithm differentiation. Okay, maybe he made this easier. Wasn't this still an awfully involved problem? Wasn't there still a lot going on? Could we have done it just from the get-go by bringing down, forget the ln's, bring down the 1/3, make it a -2/3 times u prime? Maybe that would have even been easier. So what's the purpose of this whole logarithmic thing? Him. Could we do this one? Yes. How would we do it? Big quotient rule. Better make him to the 1/2 power. And within the big quotient rule, bottom d top. Oh, hey, there's a product rule too. And then there's a chain rule and a product rule. And then there's a chain rule down there too. Could we do him? Yes. Yes. But the directions say maybe take a different approach. And what's the different approach say to do? Get in an ln. Doesn't say that explicitly. It says use logarithmic differentiation. But how can we do that if there's not a log to begin with? We're not going to put any log. Some logs have really nasty derivatives. 1 over u, ln of b times u prime. Ugh. Let's use ln. Remember, I told you he'd be nice last year. Now take the derivative. Derive both sides. Implicit. Take it as it is. What's the derivative of ln of y? Equals. Oh, didn't the ln just make it worse? 1 over u times u prime? I still have to deal with all the junk. Oh! Maybe we're not supposed to start with deriving. What does logarithm differentiation say? I'm going to go back 1 page. What does it say? Use log properties. Is that pre-cal or cal? Pre-cal. Use log properties before deriving. You guys should have stopped me. Okay. What are some pre-cal log properties? Just quick review, because if you when I start doing stuff, it's like, she's doing some sort of voodoo up there. How can I change ln of a product? Make it ln of a plus ln of b. How can I deal with ln of a quotient? ln of a minus ln of b, right? How can I deal with, and I think we wrote this down at the beginning of, the section on logarithms, section 2.7, there's 2.3, 2.4, 2.4. How do I deal with ln of something raised to a power? Look, this is the one that's going to confuse most of you. Bring the n down. This is pre-cal. Is there any deriving going on? Any derivatives being taken? No. Any calculus? No. So, we're going to do some pre-cal. You ready? Break them down. In a good way. Break them down in a good way. You guys get started, and then we'll see if your breaking down matches my breaking down. Oh my goodness. Go. Come on, break them down. I'm so ready to do it. I see a sum. I see a difference. I see a bring it down. I see 2 bring it downs. I see a sum. I see a difference. I see a 2 bring it downs. Is that what you do? Pause. Wait. Does it make sense? Yes. Why? Wait. Eyes up here. It makes everything so much better. My distracted ones. Why the plus? Because there's multiplication going on. So I can split it up. I'll focus. I'm sorry. Thank you. Why the addition? Because I have a product between x and x minus 1 to the 3 halves. So I split that up with addition. Wait, where did the 3 halves come from? I brought them down. Where did the minus come from? The division. Where did the 1/2 come from? Power of 1/2. He came down. Have I done any deriving? No. Awesome. What can I do now? Little derivative, little derivative, little derivative, little derivative. Yeah, kind of. Ready? Derivative, ln of y, what do you get? 1 over y dy dx equals ln of x. The 3 halves stays. Do we know that? He's a coefficient. He's the number in front, the multiplied constant multiple. Derivative of ln of x minus 1. And just in case, technically times u prime. What's the derivative of x minus 1? 1. Minus the 1/2 stays. The derivative ln of x plus 1 is 1 over x plus 1. And just to make sure we don't make mistakes somewhere else, times derivative of x plus 1 is 1. Not bad. So we end up with 1 over y divided dx is equal to 1 over x plus 3 over 2 times x minus 1 minus 1 over 2 times x plus 1 I'm putting a big old huge bracket, because what am I preparing to do? 59 dx alone. But we're not going to stop there, even though we're lazy. We're going to say, hold on, don't we know who he is? And who is y? Exactly, the top thing, which I am just rewriting without the ln. Remember, the ln was brought in later. Who is y? He's all of that mess. I'm just writing him in front to make it easy. Now, if the AP guys were being super mean and super nasty, there's one more thing they could ask you to do. But the nice thing is, they almost never do with these types. They almost always stick it to the man themselves. But what is a nasty thing I suppose someone could ask you to do if they were just trying to torture you? What? Distribute. I was thinking get common denominators and put it all.
Okay, that's what they did on CalcChat on one of the questions. And I was like, I'm not doing that.
Because you can stick it to the man, but if you needed to make it match and that was where all the multiple choice were, what would you have to do?
Walk out of the room.
It's algebra. It's algebra 1. Don't let algebra 1 stop you from getting a calculus problem wrong, right? What más? Oops, Lauren, go.
What does the x greater than 1 mean?
It's just talking about basically, it's for all the possible domain of ln. ln x has to be greater than 1. Don't stress. All right, one more. I told you. I was going to show you one where logarithmic differentiation is very helpful. Why? We didn't want to do the quotient rule with the product rule in the quotient rule with the chain rule in the product rule in the quotient rule, right?
Yes.
We want to do this instead. He's nicer. But this one, LNs are only useful. LNs are only useful. This one, LNs are required. LNs are necessary. Give everybody a group a high five and say, come on. We got this.
Yeah. Come on.
All right, I want you to find for me f prime of x for the following. Focus. 2x to the 3 plus x. Woo! That got intense. But some of you are like, oh, that's no big deal, whatever. Bring down the 3 plus x. No! No. Power rule does not apply because power rule, you have to have numbers in the power. Who else do I have up there? I have an x. Oh, okay. It's nasty, but it's the b to the u. I got it. A to the u times l to b times u prime. No. B to the u. To use that one, where's the number need to be? B. In the base. You need to have a number to a nasty power. This one has variables in both. B to the u fails. X to the n fails. Power rule fails. Exponential fails. There's only one way to approach this problem. Only one way. And it's LNs. This one, logarithmic differentiation is required, but pause and wait. On the AP, they'll just say, hey, go. They're not going to tell you to use logs. They're not going to give it away like that. They're going to try and trick you. They're going to give you this and just say go, and you're going to be like, it must be some rule. Bring it down, and then you have it wrong. And you fall into the poor little, well, the very full group of people tricked by the AP guys. So let them do it. Why am I saying take ln of both sides? I'm going to first go ahead and rewrite it ln of y. How can I rewrite the other side? Careful. No, you can't do that yet. Two is not to the power. There are no parentheses. So I have to split this up first. Then I have ln of 1 argument raised to 1 power. Then I am allowed to say, okay, now I can bring it down. But I could not any earlier. I could not any earlier. I'm giving you all sorts of AP guy tricks in this one. Then we say, uh-oh, our goal is to take a derivative, right? Take it. And run with it. So what's the derivative of the left? Good. 1 over y. What's the derivative of the right? 2? Wouldn't it be 1 over 2 times derivative of 2? What's the derivative of 2? That's just a number. Put it in your calculator. It's a nasty decimal. What's the derivative of any number? Even nasty decimals. Forget him. 0. Plus. Uh-oh. How do I take the derivative of the next piece? Do what you gotta do. You got this. You can think of it as 1 over 2 times the derivative of 2 is 0. That helps. Yeah. But the other way is ln of 2 is really just a number. Derivative of numbers. Then my product rule, second. D first. Derivative of 3 plus x, 0 plus 1. Plus, first, D second. Derivative of ln of x. Look at you guys. Hasn't even been a month that you've known your derivatives. And you're rocking it. Last but not least, dy dx is equal to, why am I going to put a y first thing? So I don't forget to multiply the y, another common mistake. People are so focused on the right-hand side, they totally forget the left. And we end up with ln of x plus 3 plus x over x. Of course, you guys know the AP guys. That's not good enough. What's the last thing you have to do? Plug in, plug in. Plug in what? Plug in who is y. There he is. 2x to the x plus 3. Technically that's right. But a bit confusing. Times ln of x plus. And if they were really mean, they would get like a common denominator. But I trust you guys. Hopefully you can make it match. Are we okay? We're at the end of section 2.5. This homework's better be attempted by tomorrow. But for those of you that last night just wasn't cutting it, you did the best you could, but you needed more time, guess what? You have it. Okay? Guess what? You have it. But we are going to start 2.6a. We're not going to finish. Oops, we already did that. We're not going to finish 2.6a, so I'm changing this due date to Friday. Okay? So what is your big goal for tomorrow? Finish 2.5. Your big goal for tomorrow is finish 2.5. Okay? For those of you guys that needed some grace, just so happens it worked out tonight. I'm not exactly sure where I'm splitting this homework, but I definitely want to split the sections. Real quick, how many non-seniors are in this class? A, love you all, I'm very proud of my non-seniors. B, you have retreat.
Oh, yeah. This one day, John said this is the only
On this day.
Yeah, we're gonna
Everyone said this is the only
You don't get
process.
Father's Day off? Yeah, the email, you got an email thing if there any.
Yeah.
Everyone
does. Oh, it's so annoying.
But there's no point.
Christmas on
Do you actually have the email?
Oh, yeah.
Guys, wake up.
Send that.
Leslie.
You record, so.
Yeah.
Are we gonna be doing things on that Tuesday? So you don't have to like sleep in.
We're technically,
And that
Is that for sure?
We over like had it on. Actual stuff that we had to check. So I was trying to because I never know when you're walking down the street and someone says, I'll give you $1 billion if you can find the tangent line of this circle. And then thanks, Misty.
Amen, Corey.
very possible situation.
Actual practical use of the calculus. Walking down the street, someone offers you $1 billion if you find the tangent line of this circle.
I didn't know
That would never happen.
Go home.
Oh, there's been calculus on
Come to 6. Come to first, go home, then go home.
Alright, I'll give you more details about Monday, Tuesday, my seniors, not today. We can't make the juniors jealous, guys. Okay.
I'm
I want to get up at that day.
4-day week.
Alright.
The only way I would be jealous is if you
So funny, you guys have an email about me. I didn't know anyone.
they put a chip in your mind.
Wait, so are you gonna be printing?
They bugged your phone. They bugged your place.
It'll probably be nothing new, it'll probably be practicing. Yes. So at least one of them is going to be a work day. A work day catch up day. Maybe a college application day. Anyway, really?
Ooh, I like that. That's a good one.
College
You guys
is
don't
not
have
hard.
computers.
I don't get the big deal.
Alright, we have to get through at least one page, my distracted seniors. Okay.
Put in like what class you took, it's not difficult.
Depends on how much you're stressing over your essays, though. Or how much money you have to pay for all the different apps. Review! Alright. Functions and their inverses. Pre-cal. What do we got? Inverses are reflected across who or what? Y equals X. How do we solve for an inverse function if we can't solve for it? Ooh, that just got
Switch to X and Y.
Switch to X and Y and solve for Y, and if you can't solve for Y, oh well. How do we note? What is the notation for the inverse function of X? A little -1 in the exponent, but it does not mean 3. Come on, remember. That does not mean the reciprocal. That does not read the reciprocal. This is not read f to the -1 power. This is read f inverse. Whew, I taught you something last year. Besides complex fractions. Characteristics. And unit circle. And vectors, that was a thing. Characteristics. Composition of a function and its inverse. Wait, what? What am I talking about? If you take a function and his inverse and you've done it properly, what should happen to all the extra operations, the additions, subtractions, the roots, and everything? They disappear and you just end up with excellent. Right? The composition, a function with his inverse or an inverse with his function. They always simplify down to be x. And what's going on with domains and ranges? Switch, just like the x and y get switched in order to solve. The domains and ranges switch, which means each individual point switches as well. The domains and ranges switch, which means the point switch. Not many. Not many. If any. Not many, if any. Oh, that runs you. Thank you. And you know that. Okay, so. Hey, this was like all of pre-cal, right? Was there any more in pre-cal?
Wow.
Una más. More pre-cal.
Do we need to write this?
But the nice thing is we're not going to use all of it all the time in homework. If a function, fn function, right? If a function has an inverse that's also a function, the original function is going to pass the HLT, otherwise known as the horizontal line test. If it passes the horizontal line test, then we can say that the function is either invertible, that's one snazzy way of saying it, or 1, 2, 1. Yeah, that was the thing last year. 1, 2, 1.
Okay.
That's the shortcut notation. We write it that way, but then the one is just short way. Yeah. If a function f has an inverse f inverse, if f is continuous, guess what's going to be true for f inverse? Yeah. F inverse is going to be continuous as well. If f is increasing, let's think of this one. If f is increasing, like the square root of x. Question, what's going on with f inverse? He's increasing too. Oh, that's nice. What do you think is going on with decreasing, guys? Shoot. If f is differentiable at x equals c, well, that's going to be a little bit trickier. But that's where the calculus starts. Do not do any homework from section 2.6. What are you doing tonight? Get it good. Get it done. Tomorrow we can go over the questions quickly. And then we need to finish 2.6 hopefully by Friday-ish. Before the rest of you guys go on retreat. See you guys later.
I only like it if I can do it. That's literally the only reason.
Me too, but I can't do this.
Tuesday we'll start the second half. So it's up to you.
Like pinched a nerve like in my elbow. Every time I like extend it, like move back, it feels so weird. It's so uncomfortable. I do this